We'll do the same thing by putting our right triangle in the plane, but now we're going to put our 60-degree angle at the origin. Our hypotenuse is still 1. We know that the cosine of 60 degrees was 1/2. The sine was √3/2. We can reflect that point over the y-axis, find the coordinates of this point based on the algebra that we know, find our angle measure. There's one 60 degrees, and we went a second 60 degrees, so that has to be 120 degrees. We can reflect that here. We're in quadrant 3. We have negative x values in quadrant 3 and negative y values on the coordinates of our point. We are 60 degrees further than 180. So I told you, can't do this stuff in my head. That should be a 240-degree angle measure. From here to here is 240 degrees. Again, we can reflect this over the y-axis, or take your pick, that over the x-axis, and we'll get to this point. That point has coordinates positive 1/2, negative √3/2. That point is 300 degrees, if I did that right. So now we have the sine and cosine, because remember our x-coordinate in the unit circle, our x-coordinate is the cosine of that angle measure. Our y-coordinate is the sine of that angle measure. So look how many exact values we have. We have gobs all the way around that unit circle. I want to put us in the plane, and I want you to think about something. We have, I'm a terrible circle drawer, but let's say that we are in the unit circle. We have a 30-degree angle measure, a 45-degree angle measure, and a 60-degree angle measure. I'll just draw all of those right triangles. There's a right triangle with a 30-degree measure. There's a right triangle with a 45-degree measure. And there's a right triangle with a 60-degree angle measure. We know the coordinates of these points. We know from the work that we just did that this is √3/2, 1/2. This is √2/2 and √2/2. This is 1/2 and √3/2. I want to highlight something to you. Even those of you that have had trig, I want to highlight something to you. All the rest of the way around this circle, except at the quadrantal angles. I'm not talking about the quadrantal angles. I'm talking about every other angle measure that we talked about when we were going around this unit circle, that were reference angles with our 30, our 45, and our 60-degree angles. There's only 3 values that sine and cosine could possibly be. In ascending value, there they are. Your sine is either 1/2 or √2/2 or √3/2. 1/2, √2/2, √3/2, all the way around that circle. I'm also not taking into account what quadrant we're in. I'm just talking about magnitude. Your cosine is either 1/2 or √2/2 or √3/2. And obviously, these two get mixed up the most. Yes? So envision in your mind when you're trying to figure out, okay, what was the cosine of 60 degrees? Was that 1/2 or was that √3/2? I don't remember. Look at your triangles and find a relationship on your x and y, distance. Here, for the 30-degree triangle, x is greater than y. Here's your x distance. Here's your y distance. So when I'm dealing with, okay, what was cosine of 30 degrees? Oh, well, that's where x is greater than y. And I know that on 30, 60, 90, those are the only two values. And if the x value has to be bigger than the y value, then I know that the cosine of 30 degrees has to be the bigger of those two choices. I find students don't really have trouble with 45 degrees. Let's look at our 60 degrees. I just can't remember what the cosine of 60 degrees was. But I know that it is the one that has the bigger angle measure. So it is the one where x is smaller than y. So the cosine of 60 degrees has to be the smaller of those two values. So it has to be 1/2. This is not about memorizing a lot of information all the way around the unit circle in the plane. This is about problem solving, critical thinking, and making connections based on really a very few players. Those are really the only three in play, and these two are the only two that usually get confused. So think of things like that. So that's all I'm going to say for now on exact values. Remember, we are going to move away from degrees and do everything exclusively in radians.